The unit circle. This section is all about expanding our knowledge of angles beyond 90 degrees. When we first came across the sine, the cosine, and the tangent, they were all defined in a right-angled triangle. Since the angle sum of a triangle is 180 degrees, the angles x and y must add to 90 degrees. That means if we just pick on x, for example, it's really got to be between 0 and 90. And at both of those extremes, of course, it stops being a triangle. If x is 0, it just ends up being a flat line here. And if x is 90, it stops being a triangle because it goes up there. But of course, we can turn through any angle, and we want to look at what happens to the sine, cosine, and tangent when we go beyond 90 degrees. And the unit circle is a way of doing that. The unit circle is a circle of radius 1 unit, centered at the origin here, which is the point 0, 0. Note how the angles are measured clockwise from the positive x-axis. So the positive x-axis is just here, and that's where 0 degrees is. We then go clockwise. So 90 degrees is at the point 0, 1. 180 degrees is at negative 1, 0. 270 degrees at 0, negative 1. And then when we get all the way around 360 degrees, we're back at the point 1, 0. Now remember our quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So, angles between 0 and 90 are in quadrant 1. Angles between 90 and 180 are in quadrant 2. Angles between 180 and 270 are in quadrant 3. And angles between 270 and 360 are in quadrant 4. Now let's just draw some axes so I don't have to keep going up and down and looking at that unit circle. In quadrant 1, both x coordinates and y coordinates are positive. So if we have a point here, the x coordinate and the y coordinate are positive. In quadrant 2, x coordinates are negative and y coordinates are positive. So that's for a point here. In quadrant 3, both x coordinates and y coordinates are negative. That's a point down here. And in quadrant 4, the x coordinates are positive and the y coordinates are negative. Now this is stuff that you've known for years, but it's going to become important now in regard to the sine, cosine, and tangent of angles. Consider a point P in quadrant 1. The angle between the positive x-axis and OP is acute and therefore consistent with the definitions of sine, cosine, and tangent that we currently have from RAT trigonometry. Now I'm just going to explain how we get the stuff that's written next. So we've got the point OP, and we know that this length is 1 because it's a unit circle. We've called the angle theta, and remember it's measured from the positive x-axis. So if I call this length, it would make sense to call it y, and this length x, Then, if we consider this to be the hypotenuse, this to be the opposite, and this to be the adjacent, if we're finding x, we'd use the adjacent and the hypotenuse. The cosine of the angle would be equal to the adjacent divided by the hypotenuse. In other words, x is equal to cos theta. If we apply the same thing to finding y, that would be the opposite divided by the hypotenuse, and so we could see that y would be equal to sine theta. And that's what I've got here. OQ is cos theta. We can see that on the diagram here. This is because this side of the triangle, OQP, is the adjacent. QP, as we can see just here, would be sine theta. So we discussed how to find those over here. This is because this side of the triangle OQP is the opposite. So the coordinates of P are cos theta and sine theta. So this point here, P, has coordinates cos theta, sine theta. And that's where I'm going to finish this introduction, and then we're going to go ahead and see what implications that has for sine, cosine and tangent for any angle around the unit circle.